Welcome. In this series of queries, we are going to build a toys table and a color table and populate those tables so that we can show a Cartesian product. So the question says, create a toys table, meaning toy ID and toy name, and a color table, color ID and color name, and then we're going to put 6 rows or 6 tuples in each table. And so we're going to use this with a create statement. So we'll get rid of that. And here are my 2 create statements. So I create a table toys. Notice that we have toy ID of data type integer. It's a primary key. And then we have a toy name, and that'll be character 20. A second table will be colors, and it will have a color ID and a color name. So let's run that. And it's executed. Now I'm going to put some data in there. And so, and I'll just put it in not with code, but I'll put it in through the graphical user interface. So let's go to the colors table, and let's put in 6 rows. So, and this might be small, and maybe I'll describe what I'm putting here. I'm putting a color ID of 1, and then I'll put the color red. Then I'll put the color 2, and I'll put blue. And then number 3, black. The number 4, brown. Number 5, we'll put purple. And number 6, we'll put yellow. Now notice that we have this little red item here. That just means that that row hasn't been committed yet. And so when I type yellow and hit enter, that red thing goes away. That means that row is permanently saved. So now we have 6 colors. Let's put 6 toys in here. It's a little bit tedious there, but we made our 6 toys and our 6 colors. So let's go back to our question. And it's back to here. So we have our toys and table, we have our colors, and the question is return all combinations of toys and colors. Well, that's asking for a Cartesian product. So in SQL, you do that with a cross join. So I will just highlight this query. And execute. And we will note down here at the bottom that we have 36 rows. So the whole point of this is showing what a Cartesian product is. That is, we now have red jacks, blue jacks, black jacks, brown jacks, purple jacks, and yellow jacks. And we go through each color through each toy. That's a Cartesian product. Sometimes students won't remember all the nuances of a Cartesian product. That is, if I have table A and I have table B, then the Cartesian product is going to have the total number of columns. So I add the number of columns to be the new table, and then I multiply the rows. So if I have 2 columns and 2 columns and 6 rows and 6 rows, the result table will have 4 columns and 36 rows. A nice mnemonic to remember that is to see how many columns and rows. We remember that columns are actually attributes, rows are tuples. So to find what the new table looks like, we say add the attributes and times the tuples. Okay, so that's a Cartesian product. Now the next one just takes off from where we were on this last one, and we're going to put it in a stored procedure. So we are going to get a stored procedure, and we're looking to return all combinations of toys and colors like we just did, but include only those toys with an ID larger than a value that we're going to supply at run time. Okay? So we want to have a variable that's declared, and when we execute the stored procedure, we want that to be able to take a value and then execute it. So this is my stored procedure, and the stored procedure's name is Van Halen, so it's create procedure Van Halen. In a stored procedure, this part would be optional. You don't have to have a variable to run a stored procedure. But if you do want a variable, this is how you declare it. Now, all variables in SQL Server begin with an @ sign. So this variable is named @ID. The stored procedure name, it's going to start out as Van Halen, but really what I want to do is I'm going to put a USP in front of it. And a USP stands for User Defined Stored Procedure. There are a lot of system stored procedures that are also available, but this one will be a user stored procedure. So here's the code, and I'm going to put my USP here. Note, this is a big note, that I will run the stored procedure here. And it's unsatisfying because it just says it completed successfully, but we don't see any action. We don't see any results. So the stored procedure now is permanent. It is a permanent object in the database. If you wanted to find it, you'd come over here and look for programmability, and you would see your stored procedures there. We would just come over here, open this up, collapse tables, go to programmability, go to stored procedures, and you'll see we have the USP Van Halen one on that list. So that's how we look at stored procedures. Well, let's execute this stored procedure. So you execute a stored procedure with an exec. So exec USP underscore Van Halen, and I am passing the value of 10. What happens, it executes a stored procedure, and in the where clause, you're looking for those instances where the toy ID is greater than, in this example now, it's at 12. So you're saying where toy ID greater than at 12. So we'll run this. Notice the toy IDs down here in the final answer, none of those are less than 13. You have 13, 14, and 15. So we could run this stored procedure again. In fact, we can run it as many times as we'd like. Let's put 13 in here. We'll change that. The stored procedure is already built on the server, and I can call it as often as I want. And now I only get 12 rows. If I change it to 14, now I only get 6 rows. So this is an example of a stored procedure where I pass a value and I can execute that. Now, stored procedures are very important in SQL. In fact, a lot of people call them the meat and potatoes of SQL because they write all their SQL logic in stored procedures so that they can be permanent and they can be accessed in a variety of ways. Thank you.